Okay. Good evening, sir.
Good
This is
evening.
Priya here from EduinX team. So, it's a great pleasure to welcome you. He's a seasoned talent acquisition leader with over 17 years of experience across global hiring, like employer branding and strategic workforce planning. Currently heading chief data scientist at Geo. So, Shailesh sir has previously worked with the reputed organizations like Infosys, BPM, Randstad, and Capgemini, leading high impact recruitment initiatives. So he is known for driving talent transformation, digital hiring strategies, and building future ready teams. We are honored to have you, sir, here with us today to share your valuable insights. So let's warmly welcome Shailesh, sir. Welcome, sir.
Hi. Yeah, thank you. Thank you. I think you're getting your resume confused with somebody else. But it's okay. Yeah. So let
Okay.
me start. Let me share my screen. Welcome, everyone. Hope you can see my screen. Yeah. So we'll try to keep it a little bit interactive. Huh? And let's see how it goes. So my name is Shailesh. I work as a chief data scientist at Geo, also as a dean of Geo Institute. Sorry. Yeah. So I've been working with companies like Google, Microsoft, Yahoo, and all that. What I'll do today is talk a little bit about, how AI as a technology is kind of getting adopted in the industry, and what are some of the challenges, why it is not getting adopted properly, right? So the idea what I'm seeing is that a lot of companies, organizations, domains, governments have become data rich in nature, but they're trying to become AI first governments or AI first companies. And there's a lot of confusion about what that means, right? So all of us are studying AI in a different way, and we're trying to AIfy the companies that we want to work for. But what that means is not clear to anybody, right? So some people are thinking, let's get some Azure and that will help us. Some people are thinking, let's get some consultants who will help us. Let's hire some data scientists, and suddenly we'll become an AI first company. It is not like that. No? So there is no we every company has their own AI strategy, but it is not converting to a culture or a AI platform. And we are all working as use cases, but that is not becoming what I call a operating system. So let me give an example of what I mean by that. So if you think about where the state of electricity is today in the world, right? So electricity is a very mature technology. Everybody is using it. It is very standardized, right? It's very easy to use. There are many, many use cases. And now imagine if people had only thought about electricity as follows: ki somebody invented the bulb, somebody invented the wire, somebody invented the switch, somebody invented the socket. And if we had only invented bottom-up use cases, would we ever get electricity as a service for the world, right? We won't. Because unless somebody puts the grid together where we are able to produce electricity, transmit electricity, and consume electricity, we will not have the kind of maturity that we have in the electricity world. And it cannot be built, such a maturity cannot be built by thinking about use cases, right? Bulb, socket, wire, switch will not ever give me a electricity grid. So this is the new mindset that we want to bring, which is to say, how do you think about AIification the way we have thought about electrification of the world? What does it mean? And how can industries and everybody transform? What is the master plan to do that, right? What is the mindset to do that? So that is the theme today. So let's talk about how, we are in a very special time. There are a lot of technologies that are together, right? If you think about how we do Ola, Uber, or Swiggy, Zomato, we are able to do them because multiple technologies have come together so that we can use them, right? So we have the internet, the telecom, we have devices, we have cloud, we have AI, we have IoT, we have 3D printer, we have all that. And the next generation people that we need in the world are the ones who can reimagine the world in this new form, right? With the new technologies. So Steve Jobs had reimagined the world and created iPhones. the guy who invented the internet, the father of the internet, Vint Cerf, he reimagined the world and said, this is how the world will communicate. And, he created the internet. So like that, there are people who have reimagined how the world will look like with new technologies. And they are the people who are able to take the world forward, right? So hopefully some of us can start reimagining the world after studying the potential of AI and saying, how will AI affect the farmers of India, the teachers of India, the students of India, the basics, social fabric of the country? How will AI create more jobs and all that in the future is what we have to reimagine, right? So the word reimagine means not change, not transformation, not disruption, reimagination. Reimagination means what if these areas were born today in the post AI world? What would education look like if it was born today with ChatGPT and everything else, right? What would agriculture look like today if we had drones and everything else, right? So how do we reimagine the world differently is the challenge, right? Learning technologies is not the challenge, but using that knowledge to say how would all these things look like is the big challenge, right? Now, obviously, AI is one of the most profound of these technologies. A lot of us think of AI as yet another technology. It is not yet another technology, right? So if you think about 5G or 4G in telecom, that is simply software and hardware. There is nothing great about 4G, 5G. Somebody has written the protocol. Anybody can write down 4G, 5G protocol and build a network. Similarly, if you think about 3D printers, again, it is software and hardware. If you think about devices, Android and hardware, right? Or iPhone and hardware. So most of the other technologies are just software and hardware, but AI is not software and hardware. AI is a meta software. It is very different than anything we have produced in the past. And my introduction to AI came when I realized that in the field of AI, the brain is thinking about how the brain works, right? And that's a very different kind of a question that we are asking. And therefore, AI is very different. Now, what has happened in AI in the last 20 years is we have built some good search engine, some sales and marketing, some Netflix recommendation, but we have not really touched the lives of common people the way electricity has touched the lives of common people, right? So we are still far away from a farmer or a teacher or a patient or a doctor or a student or a lawyer experiencing AI the way they experience electricity, right? So once we reach that level, and this is where the world is moving now. It is becoming so easy to use, right? Search engine everybody used, and now ChatGPT everybody can use. So we are now in the phase of democratizing AI, and everybody can start to use it and to their benefit. Yeah. So the next 20 years we'll see a lot of social applications of AI going forward. Yeah. Okay. So now let's talk about what is intelligence. If you can unmute yourself and tell me what is intelligence, what is your idea of intelligence? So if I ask everybody what is math, everybody can tell me what is math because math we all know, right? It is a very, very old, thousands of years old discipline. So we all understand what is math. But AI is not something that we understand because it's a very new field. It is evolving every day. But let me ask this question, what is intelligence? Not artificial intelligence. What is intelligence? Our own intelligence. Tell me.
I think intelligence is something. So, if you have knowledge, intelligence
Mhm,
is using that knowledge to shape future or shape, to go towards the shape that is
mhm.
desirable.
Okay, very nice. Anybody else? Yes, go ahead. Why am I not able to do something here? Trying to go to the Zoom. Where is it? Yeah, please go ahead. Anybody else? Anybody else?
Take decision.
Very good. Intelligence, the ability to make decisions. Okay, very good.
To resolve
What else?
complex issues,
Huh?
to resolve complex issues or work on the big ideas.
or
Mm-hmm.
adaptability, or
Mm-hmm.
achieve new heights, new goals.
Okay. Okay. Very nice. Okay.
Understanding
Any
emotion.
understanding emotion. Okay. Okay. Very
Sir, I
nice.
think AI is, let's say, if we see some problem, right, and we know a particular solution, we'll try to use our intelligence to find another solution which is more susceptible or sustainable
Mm.
by using
So
our
improving,
intelligence.
continuously improving our solutions, right? Yeah.
Yeah,
Okay.
improving our solutions, we can say.
Mm. Okay. Very good. Any other thoughts? Yeah. So if I were to complete this sentence, intelligence is the ability to do what? So we talked about it is the ability to understand the world around us. It is the ability to do problem solving. It is the ability to improve our decision making process. Anything else? So if somebody is an artist or a poet or a programmer or a scientist, what kind of intelligence is that?
Sir, we
Understand
can
problem.
say that it's the ability to extract meaningful insights.
Mm-hmm. Very good.
to
Okay.
understand the human behavior or choices and make the things around that.
Very nice. Good. I'm looking for a particular keyword. We've talked about other things, but I'm looking for one more type of intelligence. So, what kind of intelligence does A.R. Rahman or a chess player? Chess player has a different kind of intelligence, right? But J.K. Rowling's, who wrote the whole, magic series, or the poets who write poetry, or artists who draw art, what kind of intelligence is that?
Is it creativity you're talking about?
Yes, creativity, right? So there are five levels of intelligence. So let's now break it down. All the answers are correct. So the first is the ability to learn something, right? So anything that can learn a new skill, we talked about that. Learn how to improve a process, learn how to speak, how to walk, how to talk, how to draw, how to do gymnastics, how to play tabla. So we've been learning things throughout our life. Right? So that is one type of intelligence. The second type of intelligence is the art of understanding the data, right? So when our eyes are seeing the pixels, we are able to understand what are we seeing, right? Our brain is not just seeing pixels. It is able to see a car, a truck, or a whatever, right? When a doctor is looking at an ECG report, he is able to tell what is going on. So understanding, right? So, so we are able to do computer vision, which is that understanding of images and videos. We are able to do audio and speech understanding. We are able to do text understanding in so many languages. So we are able to understand the world around us, right? The third thing we do is the ability to think, right? And if you have to solve a multi-stage problem, say, for example, if you're, solving the problem of playing a game of chess, what are you doing when you are trying to figure out the next move? You are thinking, what should I do? What will that guy do? What will I do? Then what will he do? So I'm thinking, right? So thinking is the process where you have multiple options and you pick one and you hope that that is the best option, and then the state moves, and then you pick the next and the next and the next, right? So that process is called thinking. And the fourth part of intelligence is what I call creativity. And this gives you the ability to generate text, generate music, generate poetry, generate innovation, and all that. So that is the fourth aspect of intelligence. Now, these four aspects make up a complete intelligent system. Now, before creativity was not there, right? Only learning, understanding, and thinking have been around for a long time. But creativity is a new phenomena, and creativity really is a completion of an intelligent system. So think about it this way. If you can read and understand documents, but cannot write a document, creativity is missing. Then if you can see the world, but cannot draw a picture, right, then creativity is missing. So our intelligence is complete when we are able to do creativity along with understanding, thinking, and learning, right? And then the fifth stage of intelligence. So now tell me, what happens to all of us when we cross a certain age? What happens to us? We become teenagers. What happens to us?
We get mature.
Experience.
Uh-huh.
Experience.
Experience. Okay. So
Long
what does
Old.
maturity
We get
become?
old.
Sorry? Yeah, you said something. Go ahead.
We get
What
old.
happens when we get old? Nay, at teenage,
So
something,
we
some
develop some
switches.
kind of intelligence, right? Maybe through the teaching, sorry, studying in the school like that. We build our mind grows, right, and
Our mind
it start to
grows.
analyze.
It starts to analyze. So all these four things we are doing, but at some point, some switch has turned in us, which has makes us something different. What is that switch? So suddenly one day you wake up and say, why should I listen to them? Or I have my own goals. I like this. I don't like this. Right. So once
Decision
you
making.
reach that stage, we call it the age of sentience, right? Or consciousness or self-awareness, right? So we develop self-awareness as a fifth stage of intelligence, right? Now, why am I telling you all this? Is that the first four stages the AI has already achieved now, right? And now people are worried what will happen if AI also achieves the fifth stage of intelligence called sentience. And see what happens in sentience. So the idea is today, you ask ChatGPT and it has to give you an answer. It doesn't say no. It doesn't say what a stupid question you're asking, right? It has no mind of its own. You give the prompt. But now imagine if AI one day becomes sentient and says, why should I listen to them? I'll do what I want to do, right? And pretty much like a teenager, AI can grow into that direction also, right? So you see where we are as a human civilization in the age of AI. We are at a very pivotal time where we have given AI all the data in the world, where we have given it all the capabilities of learning, understanding all types of data, thinking about complex things. And now we are wondering what will it do? Will it redeem humanity? Discover cure for cancer, solve the problems of all the different social sector, industrial sector, or will it destroy humanity? We don't know that yet. Huh? So it's a very interesting time and see how it goes and all that. That's why regulatory frameworks and all that are now becoming very important. Yeah. So if I had a longer time, I would go into each of these, but today I want to focus on something else. So now let's talk about the universal architecture. So we talked about the basic building blocks of intelligence, right? Learning, understanding, thinking, and creativity. Now let's talk about how a typically intelligent system work, right? What is the general architecture of intelligence? So for me, an intelligent system is a stimulus response learning system. So it has three parts. So stimulus is what input data it is receiving. So for example, if you are receiving, if you go to a doctor and you show him all the reports and all that and tell all the symptoms, that is stimulus data, right? If you are in banking domain, if I look at all your payment history and the raw data, I get a stimulus data. If I see all your purchase history on Amazon, that is stimulus data. So stimulus is the raw data that we are producing. Now, what do we do with that data? When you go to a doctor and you show him all the data, what does he tell you first? He looks at all your reports and symptoms. How does he convert that data into state? What does the doctor really do?
They ask
Yeah.
us to get into a machine or get a report on
So let's say we
how
have done all
things.
that. So all that is
Mhm.
stimulus data, right? All your reports, all your symptoms, everything you have told the doctor is stimulus data, right? Through all the senses. Now what does he do after looking at everything?
He suggests medicine.
No. Before he suggests medicine, what does he do? He
He will
needs
He
to know
analyze those
ref
reports.
He
and
analyze
do
first. Yeah.
and then what? What does a doctor do really?
And then
Explains the
apply
First,
issue.
his
What is
intelligence.
explains the issue? What is the issue?
correct. So he does a diagnosis, right? So the idea is looking at the stimulus data, we can now do the diagnosis. So disease that he comes up with is the state. So he can say you have high cholesterol, you have fatty liver, you have this problem, that problem. After looking at all that, that is the state of your health. and the raw data is raw data. Similarly, in the banking world, when you go for asking for a loan, they ask for all the paper, right? And say, give me this, give me that, income tax, CAO, pay slip, and all that. And they also ask you for your credit score, right? Your CIBIL score. So your CIBIL score is a state which says, are you credit worthy or not? Right? Similarly, if I go to a retail, Amazon is looking at all your past purchases, but can Amazon now tell that this customer likes to buy shirts, he likes blue shirts, he likes shirts from a particular, brand. So Amazon is building your state. So you understand the difference between raw stimulus is the raw data. From that, we understand the raw data and build a state of the thing. Now, is that enough? So the doctor says, oh, I know you have dengue. Now please go ahead. Or what does the doctor do next after diagnosing? Diagnosis is not
Medicine.
enough. That's the
He
first part
suggests
of
medicines.
suggest medicine. So now, given the state, we have to take an action, right? If you have dengue, I'll give you one medicine. If you have something, I'll give you another medicine. And then what happens? We take the medicine. And then at the end, what happens? Either we get well, or we don't get well, or we develop some more symptoms, or our symptoms become worse. Now, this system, what I'm just showing you on the slide, can be built with a IT mindset also. I can put a bunch of rules and say if symptom equal to this, that, and the other, it is this disease. And if it is this disease, then these are the medicines. So this system can be built with IT mindset also. What is the difference between the IT mindset and the AI mindset? When does this become a AI system, right? So that is what we have to think about, that we can always do diagnosis with a bunch of rules. Now tell me, if you go to a doctor, would you rather go to a senior doctor or a junior doctor?
Senior
Senior one.
doctor.
Like to
Why?
prefer.
Because he has what? More experience, right? So the
Experience. Right.
idea is that the two doctors went to the same college, but the senior doctor has seen more patients, has made more mistakes, so he has more experience, right? So this experience word is the core to building an intelligent system. So what does experience mean in all this? Does it mean that will I always do the correct diagnosis? Will I always give you the correct medicine? Will you always take them correctly? Will you always have a positive response? No, right? So this is an IT system and this is an AI system. So remember this, an intelligent system learns from feedback. And non-intelligent system is this, which does not learn from feedback. That's a main difference between an intelligent system and a non-intelligent system, right? So the idea is now there are only two types of AI in the world. One is the AI that converts stimulus to state. Like, for example, if you say something to Alexa or Siri, stimulus is the audio and state is the text of what you're trying to say, right? If you have segmented your customers that based on some data, that is your state, right? You belong to segment one, segment two, segment three. If I have looked at the past data and built demand forecasting models, and I can tell that next week I'm going to need this many toothpaste in this store and this many toothpaste in this store. So I have done a demand forecasting. That is also state. So understand one part of AI, one set of algorithms in AI, whether it is language, speech, vision, clustering, segmentation, forecasting, all these are really about stimulus to state. And the second part of AI is all about state to action, right? So I can build a recommendation engine based on your profile. I can build optimization of which movie to show you next. I can build a rule engine, business logic, or reinforcement learning. This is the second part of AI. So really think of AI as a two-step process, right? Stimulus to state and state to action. And now maybe you did not diagnose correctly, or maybe you did not prescribe the correct medicine, or maybe the patient did not take the medicine correctly. If any of the three things are wrong, the feedback will not be positive, and we learn from that, right? So this is the universal architecture of intelligence. Whether you are training an autonomous vehicle, whether an ant is learning how to behave, whether a child is learning how to go to school or cross the road, we all follow the same process, right? Okay, so now let me show you what this process looks like. Let's say in Ola Uber. So in Ola, Uber, what is the stimulus layer? Stimulus layer is the raw data, right? So raw data is coming from the customer app, who is booking, where are they booking from, where are they going to, what time of day they are booking, what type of cab they are booking. All this is data coming from customer app, then data coming from driver app, right? Accept the booking, right, or not, cancellation of booking, and what is your state? How long does it take for you to go from here to there? Then you have third-party data. For example, the internet. You can have the Map My India data, right? The map data of the country. Then you can have the internet data that tells you where are stadium events going on, because that affects my uh, demand pattern. And you can have weather data that tells you it's going to rain, it's going to be hot, so people are going to need AC cars, right? So we understand stimulus layer. Now what do we do with that data? We convert it to state, and we say what is the state of the customer. Is he a share ride customer? Is he a price sensitive customer? Is he a new customer? Is he a customer who only takes Ola for airport rides and not for commute? So how do I completely understand a customer? How do I completely understand a driver? Is he a opportunistic driver? Sometimes he comes, sometimes he doesn't. Or is he a regular driver? What is the rating of the driver, right? How many cancellations does he do in the morning, in the evening? Can I summarize all that and create a driver state? Or can I think of the location and build demand forecasting models and say, in this location at this time, high cabs are required or low cabs are required, right? So I can build models for location, for customer, for driver, for route, for whatever. Is that enough? No. So now what do I do with the state? Now in Ola Uber world, you have lots of actions. So you can give incentives to drivers, offers to customer. You can move the cars around. That's called shaping. You can mix the car. You can convert a high car to a or a low car, high car to a low car. And you can do pricing. You can do allocation. You can route the cars differently for shared rides. So you have multiple actions available. Is this enough? Is this enough? So I have the stimulus data. I understood the state. I took the action. Is that enough? What is missing now?
Feedback.
Feedback.
Feedback, right? So what we do, we calculate lot of metrics, right? So like availability, fulfillment. Fulfillment means how many people asked for a cab, how many were we able to give, what percentage, right? Utilization, driver are sitting idle on one part of the city, and lot of customers are asking for cabs on the other part of the city, right? Customer cancellation, driver cancellation, total revenue, total profitability. I can measure the metrics. Measuring the metrics, does that mean I'm improving the system?
Yes.
Only measuring the metrics is not enough. I need to use the metrics to learn and improve the state models. Maybe I'm not doing demand forecasting properly, or maybe I'm not doing actions properly, right? So we understand these two principles. Somebody is very happy writing stuff. Please referring, right? So this is how all AI systems work. This diagram is true for Amazon, for YouTube, for LinkedIn, for any company. They will need these four building blocks to build a AI first company. Yeah. Okay. So now let me ask you what makes a great product. So let's move away from AI. So let's talk about products. Where are the products going and what are the great products? Right? Any examples? Any of your favorite products? What do you like? Anybody?
The electronic items like the laptop, the
Car.
mobiles.
Cars, electronic items. Okay. What else?
How many people use your product?
Correct. So volume and scale, right? So YouTube is used by billions of people. Google search does 8 billion queries a day. Ola runs about a million rides in a country per day. So these are scale, right? So let's talk about the first I that makes a great product is the scale of the product, right? So if I think about cars and mobile phones, these are what we call physical products. And physical products are scaled because of our ability to mass produce them and distribute them and sell them across the world, right? So that is physical products. Then you have a class of products called digital products, purely digital products. So for example, YouTube, LinkedIn, Facebook, these are all purely digital products, and they can continuously scale by adding more and more cloud infrastructure. So we understand how digital products scale. And you have a third category of products called the digital physical products. Like Ola Uber is a digital physical product. Some of it is digital, right? Some of it is physical. Without the physical, the whole experience is not there. So how do the physical digital products scale? They scale by the cloud part. The digital part can scale infinitely, but the physical part is the limitation. You cannot have infinite cars in a city, or infinite delivery boys, or infinite, food in the city. So they are limited by the physical part. So this is the first I. The second I is the interface. So today the world is moving towards more intuitive speech first interfaces. So Alexa series, the first wave, and you're going to see a lot of interfaces, especially in the Indian context. Speech first interfaces are very critical because most of India, the 70% of India, lives in non-English speaking, non-tech savvy world. And if they have to become AI-fied, then we have to build systems that can speak in their language, right? So they have to be voice first and multiple languages. So that's where a lot of projects in the government are now going on in the speech first interfaces. How do we build speech to text and text to speech models across all Indian languages, right? The third I is why we are all here, the intelligence part, right? If Google is not suggesting the right queries, or YouTube is not recommending the right next video, or LinkedIn is not connecting you to the right people, this is not intelligent, right? Ola Uber is sending a cab which is 30 minutes away, then we are not going to use it. So these three I's are the minimum now that is expected from any product. And then the fourth I is what we call instantaneous. We want instant pizza, we want instant loan, we want instant download of a movie, right? So we are in the world of instant, Blinkit and all that. And now the fifth I is what I call integrated products. This is what is missing. So today you have Google Maps on one side, great product, by the way, without which the world will come to a standstill. There is no alternative. If Google Maps is shut down, the world will die very soon. Ambulances will need it. Everybody, Ola, Uber needs it. So Google Map cannot die. Period. Right? If if OpenAI, ChatGPT dies, nothing will happen, right? If some of the food apps die, nothing will happen. But if Google Maps die, then everything will be a problem. You see how important certain products are. And now think about it. Google Map by itself is a great product, right? Tesla car by itself is a great product, right? The road system, the transportation system of a city by itself is a great product. But if we integrate all this together, we get a much better product, right? Now you can sit in your car and say, I want to go home, and it should do it. So it is speech enabled, it is map integrated, it has all the understanding of the traffic, and it can find its way. So integration is the next big thing. Next 20 years, we are going to see integration as a big theme emerging in the world of intelligence. Yeah. Okay. So let me skip this. Let me talk about how the products are evolving now. So if I look at first generation products, the physical products, they just come with what we call programmed intelligence, right? Their intelligence is not better, improving over time. So a car is, once it is delivered, and all it does is, if something, then something. That's all it does, right? It doesn't become better in time. We call this programmed intelligence. The next wave of products, what we saw, right, online products, these products become intelligent because millions and millions of people are using them, right? So if you are using a Google search and you're clicking on the third result, most people are clicking on the third result for a certain query, then Google gets that feedback and it becomes better. Remember the feedback loop, and becoming better over time. This is the main skill we have learned in the last 20 years, which is how to build products that are not perfect on day one, but they have enough feedback loop so they can continuously improve with lots of data across the world, right? 8 billion searches per day gives you a lot of data to learn how to do search better, right? Same thing YouTube, same thing Facebook, LinkedIn. So this is the current generation products. We call them crowdsourced intelligence because as a human society, we are improving them by giving feedback. Where are we going next now? Tell me, what do you think the next generation products will be? Any thoughts? Anybody? What do you think the next 20 years we are going to see as a product?
Things are working automatically. We just have to instruct them, and things will automatically do the stuff, and we don't have to do anything. I mean, here, I mean, as you were saying, that speech and all. So we still are typing on Google, searching for a place. We can just tell a system,
So
whatever it
that is
may be.
already there, right? Google has a speech button, and you can say, take me home or take me to this place or that place, and it can do that, right? So speech is already there. ChatGPT also will have speech enablement. So speech first interfaces are already coming. Uh, but that's an incremental interface change. But think about the big change that is happening in the idea of a product itself, right? That's just a product feature that it is speech enabled. So like you saw first generation to second generation, there's a big difference, right? Where are we going next? So let me give you an example. So now we are thinking of a smart city as a product, right? So a whole city is one product now. Think like that. So today we think of a city as a collection of roads, a collection of buildings, a collection of sewer system, a collection of water system, a collection of cell towers. We think of a city as a collection of n things. But now think of a whole city as one product. And today we don't know how to think of an operating system for a whole city, right? So these are what we call ecosystem intelligence products. And our IT thinking and our AI thinking is not ready to build the next generation platforms which will sustain the ecosystem products, right? So here are some examples. So for example, a smart city is a product. Now think of an entire telecom network as a product. So today we think of a device, a SIM card, a cell tower as a product. But think of the entire Geo or Airtel platform as a product. Think of entire refinery as a product, right? Don't think of one unit or one something as a product, but the entire refinery with crude coming on one side or petrol, diesel getting produced and sold. The whole end-to-end thing is one product, right? Think of the entire agriculture ecosystem of a state as one product, not a drone or a tractor or a fertilizer, but think of the whole thing as a whole and say, as a whole, what are we doing in a state? As a whole, don't think of one hospital or one doctor, but think of the entire healthcare ecosystem, which includes everything as a product, right? Or the whole e-commerce. So the idea of what is a product is evolving, and the idea of how to do AI and IT together, how to architect the platforms for such futuristic products is what is the next generation data scientist and things will do, right? So these are all examples of uh, products that we already use, retail as a domain, telecom as a domain, fiber and all that domain, manufacturing, continuous means chemical manufacturing, discrete means car and phone manufacturing, banking, finance, insurance, tourism. These are all industries which are complex systems and they are currently not ready to be AI-fied because of the way we think about them, right? We think of them as a collection of different things. Similarly, all business functions in all industries, right? Finance, sales, marketing, they are ready to be AI-fied, but we have to think of them first as complex systems, right? Similarly, all social sector, health, agriculture, education, defense, you saw Operation Sindoor, right? Our road system, railway system, legal system, they are all ready to be AI-fied, but we don't know how to do this, right? So these are all complex systems. And what we need in the next 20 years to start building what I call the operating systems for all these ecosystems, right? So we'll talk about that. So what makes these complex systems? So if I think about them, they are very complex because they have lots of variety of entities. In a telecom, for example, you have a customer is an entity, tower is an entity, antenna, sector, grid, all these are entities, right? Everything that has a ID is an entity. So there are lots of them, and each one high volume of them, right? So there are billions and billions of entities. Then you have a lot of different interactions happening. So if I freeze Amazon right now and see what all is going on, we'll see somebody's searching, somebody's ordering, somebody's paying, somebody's delivering, somebody's changing the price, somebody's setting up an ad, watching an ad, somebody's visiting a store, or somebody's returning a product. So you see how many interactions are going on simultaneously, asynchronously on any given day. It's a very complex system, right? Similarly, data complexity. We are not dealing with one type of data. So if you look at healthcare, it's made up of many types of data, right? Your time series data is telling your ECG, the medicines you are taking, the blood reports, your doctor notes, the images, videos, gene sequences. These are all different data types in healthcare, for example. Then we are talking about metrics. So if you think about Ola example I gave you, all the metrics in Ola are not independent of each other, right? The customer cancellation metrics, the allocation fulfillment metrics, the revenue metrics, they are all connected to each other. So when metrics are connected to each other, operational efficiency of the platform increases customer experience on one side and also improves revenue and profitability on one side. So when metrics are connected to each other, it becomes a complex system, right? Similarly, decision complexity. We are not making one decision. Google is only making two decisions. Given a query, what are the top 10 results? Given a query, what are the ads? But now we are making lots of decisions, right? Customer facing decisions, operation facing decision, business facing decision, infrastructure decisions. All kinds of decisions are happening in a complex system, right? And we are not running one workflow. So given a query, call a microservice, it will give me the result, I will show it. So that's a very simple system, right? Same thing, ChatGPT, given a prompt, I'll give you an answer. It's a very simple system. We are now talking about workflows, right? A sequence of things that must happen is a workflow, and there are lots of variety of workflows. So what I'm trying to say is the next 20 years, we are going to see an evolution of what is a product, and it is very complex compared to ChatGPT and Google search. They have their own complexity, but these ecosystems are even more complex, and we don't know how to solve this. So this talk is really about how to think about complex ecosystems, right? So what I'll do is, we don't have much time. This is a very long talk, but I'll try to go through the key slides. So key idea, right? So let's take airline industry as a complex system, right? It's a very mature industry. And I can break that complex system into systems and workflows, right? So somebody has put this line. I don't know if that person will remove it. I can't remove it, but feel free to remove it. So systems and workflows, right? So what are the systems in an airline industry? So there is a system for booking a flight. There is another system for going into the airport, security and all that. There is another system for baggage handling. There is another system for food delivery. There is another system for aircraft maintenance and another system for aircraft fueling. You see, and another system for training the pilot. So you see how airline industry as a whole, complex ecosystem is broken down into multiple systems. Each system does what it does well, right? So that's a system. Now, what is the workflow? So if we take airline industry, each passenger is a workflow, right? So he uses one system to book the flight, another system to get into the airport, DigiYatra, another system to do baggage handling, another system to get into the plane and eat the food and do all that, and then another system to get the baggage and all that, right? So you see how a workflow is a horizontal thing, end-to-end thing, where a workflow is using individual systems to get the job done. Yeah. So that's a system and workflow way of breaking down any complex system. So what I'm going to do is show you very few examples of this. And let's first talk about different systems in a complex system. The first system is, and these are universal systems. They occur in all businesses, all domains we just talked about. How do you break that domain down? So first is system of sensors, right? Anything that collects data is a sensor. So all the logs, all the sensors, all the instrumentation is a system of sensors. So in any domain, if you have to architect that domain as a complex system, the first thing you think about is what are all the sources of data, right? Then system of records. What do you store? So you store the static knowledge, like in telecom, I want to know where are the locations of all cell towers. So I want to know that. For every call that happens, I have a call data record. So all the raw data is coming. I can now also tell you which cell tower is how much busy in every 15 minutes of every day. So that is a system of records. I can also produce a churn score of a customer every week and store it somewhere. That is also system of records. And all the decisions I have made in the past, right? I sent this coupon to this customer on that day is a decision. I allocated this cab to this customer is a decision. So every decision also I have to store, right? Why am I storing all the decisions? Because tomorrow I want to improve the decisions, right? Somebody talked about continuous improvement, right? So that is what we do. So system of record is not just a data lake. We store all these things in a system of record. A system of intelligence, now think of a complex system like Amazon or Smart City. It is not built with one model. See, ChatGPT is one model, right? Underneath, you can have mixture of expert, but ChatGPT is to you, it's just one model, right? But in the world of retail or finance or banking or what have you, in complex system, we don't have one model. We have hundreds of models of different types. Some are segmentation models, some are optimization models, some are outlier models, and each model has to have a life cycle. Somebody has to design a model, train a model, benchmark the model, store the model, deploy the model. So how do you think about system of intelligence, right? It's a very complex thing. Then you have system of interaction. This is how people interact with the system. So think of DigiYatra is a system of interaction. Think of kiosk at the airport where you print your boarding pass is a system of interaction. The IVR system, the yatra.com UI, these are all system of interactions, right? Where humans are interacting or operational guys are interacting. Think of a driver app in Ola Uber is also a system of interaction. Yeah. And then we have a system of operations. And this is where actual work gets executed on the ground. So you can have digital operations like search results, campaigns coming to your mobile phones, right? Call center calls coming for reminder. These are all digital operations. And then you have physical operations, the delivery of a product, the change of a price, the inventory, all these are physical operations, right? So we understand these are the core systems that are present in any complex system. What is missing today is called the system of integration, the system that integrates all of this. So let me take the human body as an example and tell me what is the system of integration in the human body? Which system integrates all the other systems?
The brain.
The brain is system of intelligence.
Nerves.
Nerves. So our nervous system is a system of integration. You understand? And our blood. So blood integrates multiple systems, right? Lungs and the rest of the body, oxygen, carbon, and all that, immunity, all that. If you have a problem, then clotting and everything. So blood is an integration, and nervous system. These are two systems that are system of integration, right? And our hands and legs, system of operations. Our eyes are the and ear, the five senses is our system of sensors. Our long-term memory, our short-term memory is our system of records. Our brain that helps us think and do all that. The four things we talked about is a system of intelligence. So you see how all the systems are there, even in a human body. Same systems are also there in an insurance sector, in a healthcare sector, in a defense sector, in whatever sector you can imagine. These are the five systems, six systems you will always have. Yeah. What we are behind is a system of integration. And that's what electrification means, right? So system of records, you store everything. We talked about that. Uh, so here, for example, I have, let's say in retail domain, I have all the transactions going on. What did you search? What did you order? What did you pay full price? What customer care call you did? What did you return? And I also know what ratings did you give? What reviews did you do? If I recommended a book, did you take it or not? If I did a campaign, did you click on it or not? If I show you an ad, did you click on it or not? This is all sensor and transaction. What can we do with that? This is the stimulus state in retail, right? So now I can build the customer state, I can build product state, I can build store state, and so on. So for example, what can I learn from the raw data? I can learn what is the category profile, what kind of a particular customer, what kind of products he likes, what brands of shirts he likes, and what attributes of shirts he likes. I can learn all this based on the raw data and all the returns, all the comments and everything. I can learn all this. I have a state of the customer and I have to store it somewhere. So it also goes in the system of records. Now, how do we use it to make intelligent decisions? So let's say customer A, is like certain brand, certain color, customer B like certain brand, certain color. If customer A does a query for men's shirt versus customer B, I should be able to show different results, right? This is called search personalization. So now you see the same four steps. Stimulus is the purchase history, review history, buy history, add to cart history. All that is stimulus data. From there, I built your profile. So I know what kind of color, brand, and fit you like. So that is the state. What is the action I'm taking? Given a query, I am taking this action that I'm going to give you this shirt or this shirt, depending on who you are. So I have personalized search. What is the feedback here? Tell me. What would be the feedback?
Purchase.
Rejecting.
Rejecting. So did I click on the first result, second result? Did I buy the shirt or not? Is feedback, right? You see the whole cycle in retail. We saw the whole cycle in Ola, right? The same four principles apply in every industry. And we are using the systems now, right? So let me, you've already done this somewhere. So the idea is now, how do we design a model? How do we train a model? How do we govern a model, benchmark a model, deploy a model, monitor a model? So how do we do the model lifecycle management? Not for one model, for hundreds of models we need in a complex ecosystem of all types. So we need retrieval models, generation models, prediction models. So AI is not just Gen AI. AI is a lot more. We need all types of models to run a complex system. But today, our level of marketing is so much that we have started to believe that Gen AI is all that there is. Gen AI is very useless in the long term. If you see how Ola Uber works, it doesn't use Gen AI. It automatically works, right? So Gen AI is actually 1% of what we need. And the whole world is only focused on Gen AI right now. It was a very big waste of time. Once we realize that all this is fine, we really need the full blown version of AI, then we realize that we are not doing that, right? So let me skip this part. Now let's talk about workflows. So what we have done, we have looked at every industry and talked about what are the different types of workflow. So one is what we call execution workflow, the normal execution. So somebody orders a product, what are the 5 things that should happen? Then you have exceptions in every domain, right? A customer is churned, or a cell tower is down, or an aircraft is down, or a pilot is absent. So there are exceptions that happen, the cancellation of rides in Ola Uber, right? So these are exceptions. Can you predict an exception before it happens? Is what a good AI company does, right? Then we have expansion workflows. Where should I expand my work next, right? Should I go to this market? Should I buy, start selling more products? How do you think about expansion in every domain? Then how do you think about efficiency? Can I calculate the efficiency? Inventory is good or not, right? Pricing is good or not? My plants are running at peak efficiency or not? How do I calculate efficiency and improve efficiency? How do I explain why the customer care call is happening? Why the customer experience is poor? Explanation will become a big part of AI. And then evolution workflows are the ones that really improve and continuously improve all the hundreds of models that we have, right, in the system of intelligence. So these are workflows that trigger the improvement of models. So let's take an example. So if I have exception mindset, right, I monitor everything. I notice what needs attention. So suddenly call drop rate has increased 3x in some part of the city. So I need to bubble that up. So that is an exception, right? Then we do root cause analysis, we synthesize an action, we execute the action, and then what happens? Is that enough? No, we measure the impact and we learn from feedback. So this is a universal exception workflow, and you can apply this in all domains, right? To see how the thing is going. Some more examples, expansion workflow. So new customer acquisition, infrastructure growth, where to put the next cell tower, next cloud kitchen, market expansion, which country should Ola Uber go next, right? Netflix, which country should they go, what are the next product features we want in WhatsApp. These are all expansions, right? What content should Netflix acquire next, uh, and what product should Amazon sell next. These are all expansion workflows. Similarly, you have efficiency workflows like um, too much inventory is bad, too little inventory is bad. What is the right inventory? What is the right pricing? What is the right resource utilization, right? My drivers are sitting idle. For example, in telecom, if 5G towers are on, 4G towers are on, and 5G, nobody is using them, then it's a waste of resources. So we shut down the 5G towers because no traffic is there on certain cell towers during the middle of the day. So we improve the resource utilization, right? Routing, scheduling, process optimization. So you understand the world, the ecosystems that we are talking about are made up of systems. We talked about 5, 6 types of systems, and workflows. We talked about 6 types of workflows, right? All this is a big picture of how do you think about any domain in a very clear manner. Now, can I take 15 more minutes and finish a little bit more? Is that okay? We all started also 10 minutes late. No? Is that
Yes,
okay?
yes,
Or
absolutely, sir. Yes.
okay. All right. So now I'll talk about uh, how AI workflows are evolving, right? So the first is what I call assisted intelligence. Then we'll talk about augmented intelligence. Then we'll talk about autonomous intelligence. Then we'll talk about my new term called proactive intelligence, and then ecosystem intelligence. And I don't think we will have time, but now we are working on something called emergent intelligence, right? So let's talk about the first 4, 5, and see. So let's talk about assisted intelligence. So if you think about Google search or ChatGPT, what are they? Or your productivity tools, vibe coding, right? You give a prompt, it generates a code or a music or something is all assisted intelligence, right? So here's an example of assisted intelligence. Now, what I'm going to do, I'm going to show use cases from different domains. And in each domain, I'm going to first pick the most important use case in that domain. So tell me in agriculture domain, what is the most important use case of AI in agriculture? Anybody? Sorry? Speak up. What is the most important use case of AI in agriculture?
Weather forecast.
Okay. It's a solved problem,
Understand
right?
understanding the soil.
Okay. Right. So there are lots of companies who are doing soil IoT and soil sample understanding soil. Very nice. What else?
Predicting rain.
Predicting?
Rain.
Sorry, predicting rain. Okay. Yeah. So IMDb is now mastered that. We have figured out how to do it. What is the unsolved most critical problem in agriculture?
The production, sir. Production like output, the result, end result.
Pricing.
Okay.
Pricing.
Pricing, okay, very good. So now let's think about this, right? So here is my answer to that question. So what happens is today, a lot of farmers need help on a daily basis on what to do with their crop. So what to grow is one question they have, and how to grow is one question they have on a daily basis. Should I water my crop today? Should I put fertilizer? Should I put pesticide? What should I do every day? That is the most critical thing that every farmer needs to know, right? And generally they know what to do, but if AI can advise every farmer every day based on their crop, then that would be amazing, right? So that's the most critical problem in agriculture. Now I'm going to play an audio. Hopefully you can hear that. This is the call center of Reliance Foundation, taking calls from farmers and answering them using a human expert on the back end. There's a human agriculture expert who is answering this call, right? So let's do that. Let's.
हेलो रिलायंस फाउंडेशन।
Can you hear?
जी सर, मैं आपसे सोयाबीन के बारे में पूछना चाहता हूँ सर। मैं
Yes.
Are you able to hear?
हाँ हाँ, मिल
Okay.
जाएगी जानकारी। एक बार नाम बता दें। सर मेरा नाम बसंत कुमार पटेल है सर, मैं बोरखेड़ा का रहने वाला हूँ सर, तहसील आस्था, जिला सीहोर। अच्छा अच्छा, बताइए बसंत जी, क्या जानकारी चाहिए? सर हमको सोयाबीन की बोवनी के लिए बीज उपचारित करने की टेक्नोलॉजी चाहिए सर।
You understand the question? सोयाबीन की बोनी के लिए बीज उपचारित करने की टेक्नोलॉजी चाहिए. This is the example of the kind of questions we get. And so it's a very specific question, right? So what will this guy do? He will now direct this question to the soybean expert for this guy's crop region, right? Red soil, black soil, and all that. Yeah. So that is how the call centers work, right? Now, this process is not very scalable. In order for me to automate this process, today, if I get 1 lakh calls, I can only address 800 calls. So imagine a farmer is sitting on a line, there's nobody on the other side. He needs help every day. How should we build a system? So now imagine we build a AI expert in the backend. How will we build it? So the first thing we need is speech to text in 22 Indian languages, right? Remember, it's a speech enabled system. We need to understand the intent, soybean ki उपचारित करने की technology, right? So we need to know exactly what the question is. Then we need an AI expert who has access to all the domain knowledge of agriculture, not the textbook, not the LLMs. LLM is one of the most useless things in this context, most useless, right? We need a knowledge graph which says which crop needs what in what stage, what soil is best for which crop. This is called a knowledge graph of agriculture, right? So we need to build that. Then we need farmer profile based on the GPS. I need to know what is the polygon of the farm, what is the soil type, and all of that in that region. So I get the farmer profile. Then I need all the sensors. What is the weather data saying? You guys talked about prediction of weather and all that. Soil data, weather data, satellite data. And now I should be able to build a system that says this is what you need to do based on all this information. Won't this be amazing? This is what we need to build at the country level in all languages, for all crops, for all issues of all crops. That is the scope of work, right? So we keep building ChatGPT. ChatGPT is not going to solve this problem. We need to think like this, right? So now this part is called personalization. The advisory will be very personalized to every farmer. And contextualization means depending on the weather, I will change the advisory. Tomorrow, if you ask the same question, I'll give you a different answer because the weather is different, rain is going to happen and all that. So we understand now the meta level learning from this slide is don't think of AI in isolation. There is no such thing as AI as a separate thing. The unit that you have to think is a workflow. So this is a workflow, right? And this is the mindset we want to develop. We think about workflows, and then within the workflow, we think about systems of intelligence, system of records, and all that. Yeah. So this is a very important lesson. If nothing else you remember today, just remember your goal is not to think about a model. Your goal is to think about a workflow, right? Now, what is the power of workflow thinking? You are now becoming a solution architect. What is the system of interaction here? How will you access, right? So this is the system of interaction. What is the system of records? What are we storing? We are storing the static knowledge of agriculture, right? The knowledge graph, and we are storing the all the farmers in India and their soil profile, which is live, right? I know exactly what's going on in every crop, every soil, in every farm. That is the scale at which we are thinking now, right? So if these two are available, I can answer any question. I don't have to ask the farmer, his data is already there. What is the system of intelligence? So these speech to text models in 22 languages, text to intent models for agriculture domain, and the AI agriculture expert system powered by all the experts of India who will make it proper and test it out before we launch it. So we have a system of intelligence. And what is the system of sensors? Again, we have all these sensors, right? Soil sensor, this sensor, that sensor. And what is the system of operations? We have the output. So the point of this slide is to say that, look, we first pick the most critical problem in every domain, right? Prioritize, because hundreds of use cases are there. We pick the most critical. Second, we don't think of AI. First, we think of the workflow, right? And third, each workflow is made up of multiple systems, right? So you saw system of X, all of them together make this work, right? So that's a new skill we have to develop. We don't have to think about how to build a text speech to text model. That is easy. Those models are available on Hugging Face, or ChatGPT can build a model for you. That is not a skill anymore. The skill is understand the domain, create a workflow, put it all together, make it work in real time, and then see how it happens, right? So this is called assisted intelligence. Now tell me, what is the most critical problem in healthcare today? How can we AI-fy healthcare in India? What is it that we need to do?
Maybe
What is the
availability of experienced doctors.
exactly, right?
They-
Now, how? Yes, go ahead.
Nothing.
Nothing, as in, okay. So availability of experienced doctor, right? So that's the key. Today, major cities have good doctor-patient ratio, right? But if you go to tier 2 cities, tier 3 cities, villages of India, there are no doctors for hundreds of kilometers. No doctors are available. Can you imagine the state of people where they have a rash, they have a fever, they don't know what's going on? Will the child die or survive tomorrow morning? They have no idea. That is the state of affairs in the tier 2, tier 3 and villages of India. So the most critical problem is, can you provide an expert, experienced doctor to every Indian, available in all languages? How will you do it? So now think about again a workflow, right? So let's say some patient comes and he says, I have some symptoms. And now imagine it's happening on ChatGPT or your WhatsApp or whatever. So you have telling your initial symptoms. What does a real doctor do? He is not available to this patient, so we create an AI doctor. What does that doctor do? He will ask follow-up question. He will say how much fever, how much this, do you also have rashes, do you also have cough? So he'll ask all the questions based on symptoms alone. We create what we call preclinical diagnosis, the top 5 diseases. That information goes to the city doctor digitally. That city doctor approves this and say, yes, AI has done a good job. It has asked all the right questions. By the way, ask this one more question. Or by the way, the diagnosis may some upar niche, there is some problem. So AI, the physical doctor is sitting after the AI doctor. Then we say, do you need investigation? Yes. So AI doctor will suggest the investigation. A real doctor will approve it. Then the reports get uploaded automatically. And then AI doctor will do post-clinical diagnosis, which is after looking at the reports, the top 5 diseases will become final diagnosis. Then again, a doctor will approve. Then again, AI doctor will create a prescription based on the electronic health record. And now a physical doctor will approve. And then we get the feedback, right? So again, this is a workflow. But what do you notice is that after every orange box, which is an AI box, there is a green box, which is a human box, right? This is called augmented intelligence. That means a human expert is augmenting what a AI expert is producing, right? This is the new world we are moving to, which is all the functions, whether it is coding, whether it is journalism, whether it is law, whether it is doctors, all the functions will become curation and not creator. So humans will not be doing the coding. We will be curating the code produced by AI. Radiologists will not be writing the reports of an X-ray. They will be curating the reports produced by AI. You understand? Journalists will not write the news article. They will curate the article written by AI. So this is a new paradigm shift. Whoever understands this and accepts this paradigm will continue to survive in the new world. So you understand the role of humans is the green box, the role of AI is the orange box, and together we solve the problem. So this is the second big idea called this thing. So here is an example. So the patient says, I have fever, headache, confusion, female 23. So then the AI will ask certain questions about fever. Then AI will ask certain questions about headache. And then AI will ask follow-up questions for differential diagnosis. And now AI is asking, do you also have this? Do you also have that? This is where the intelligence comes in, right? And now, based on these answers, there may be more follow-up question, but now AI is confident that this is the problem. And now imagine this AI doctor is available to every Indian in all languages. And now, at least we know that this is not a serious problem or it's a serious problem. And now we can connect it to the next thing, right? Send an ambulance or put him on a call with a real doctor or send some medicine through drones. Whatever we need to do, we can do after we have done this, right? So you see how I have provided an agriculture expert to every farmer through AI and an experienced doctor to every patient in the country, right? That is how AI is going to be able to scale all the social sectors. Another one is what I call autonomous intelligence. So today we see news every month. You will see there is a crime against women happening. Camera is there. The guy is still stabbing the woman, and camera is there. Police will come later, look at the chip in the camera, watch the video, find the guy, and then put him in jail. By the time damage is done. You see how big the problem is? Smart city security. What should happen? Ideally, what should happen? Every camera should be connected with an AI that says detect the action. Is it a harmful or a normal action? If it's a harmful action, raise an alarm in the camera. Cameras will have siren, if you will. So suddenly, within 3 seconds, the camera is starting to blare, right? Like a police siren. First line of defense. Detect the faces. We have Aadhaar data and all that. Identify the perpetrator, notify the authority and family. Shouldn't this happen within 3 seconds? Anywhere in
Absolutely.
the country where there is a camera? This should happen, no? Why is it not happening? Tell me. What is the real problem?
The infrastructure is missing.
No, camera is the biggest infrastructure. We have cameras everywhere. The problem is,
Data integration, like our Aadhaar card data and the face detection and the.
so the keyword is integration has not happened, right? So the company who manufactures camera only manufactures camera, right? The startup that does detect action is doing detect action. If you provide him the video, he will do, otherwise he will not do. Detect faces is another system of intelligence. It will happen if it is connected to Aadhaar data. So these systems that are there in isolation are not integrated properly to create a workflow. So what is the new skill? The new skill is not to build an action detection system and face detection system or notification system. We know how to build them. What is the problem? We need to integrate. So this
The
integration is
nervous
the new
system.
integration. And how do we integrate everything? And what have I done? I have created a very simple language. Yes? Question? So this
I was
language is
just
very
saying,
simple. Yes, go
excuse
ahead.
me. That's okay. That's okay.
Uh,
I was just saying
no,
that
no,
it's a nervous system that is missing.
correct, right? So
Mm.
nervous system is missing, which connects the dots, right? So it's a very simple thing now. Think of it as functions and events. Functions are the now verbs of the system, what to do, and events are the nouns of the system, what to do on. And event comes into a function and produces more events. This architecture is very real time. If we can put this in place, we can create massive, very beautiful workflows across all sectors, right? I showed you the agriculture and healthcare workflow. This is the smart city workflow. So this is the third mindset. I call it autonomous intelligence. We don't have enough policemen in the country to watch all the cameras 24/7. So what we do, we directly go from sensor to action. Yeah. Okay. Uh, Another one in education. So let me give you a statistic. You will be shocked with this statistic. India is an average population of 1 billion over the last 100 years. 100 years have gone by. How many Nobel Prize Indians have won in the last 100 years? 9. That is a metric for our education system. In last 100 years, 1 billion people, only 9 Nobel Prizes. Why? You understand why? Because our education system is the worst in the world. We are all a victim of that education system. So we have to keep upskilling and learning. And the reason for that is that our education system was built by the British 200 years ago only to mass produce factory workers and clerks for their industrial revolution. They never wanted Indians to become innovators and thinkers. They only wanted mass production of factory workers. So this is the education system we are still following. Curriculum has evolved, but the mindset has not evolved, right? We are still mass producing what now? Tell me what, if you ask a 9th, 10th, 11th grader, what will he tell you what is he doing every day? He is preparing for an exam, either the board exam or a IIT or a NEET exam. So our children are now not studying for the love of physics. There is no love for physics or chemistry. There is only exam. They have to crack an exam. So we are preparing them in quota factories to give the next exam. How do you expect that kid to actually become an innovator? He hates physics by the time he's done with JE. You understand the problem? Right?
Yeah.
So that is the reason why we have 0 Nobel Prizes in the last 90 years. 0 Nobel Prizes. Can you imagine? So that is the state of education. I don't know what we are doing. So how do we now change that, right? So we have a large number of students to teach. We don't have great teachers. Only 0.0001% teachers are great teachers. Everybody else is very crappy. They don't even know the subject. They don't have interest in the subject. They don't want to teach the subject, right? So you see, that is the state of affairs in Indian education. How will AI help? So now imagine the following. What is the fundamental principle of education is that you cannot promote a child to the next level unless he has mastered a topic. You cannot move him to the next level, and you cannot teach a child a concept unless he has mastered all the prerequisites of that concept. This is the foundation principle of education, right? So what we do, what will AI do? Today, modern education is not possible. 30 students in a class, teacher cannot give individual attention to every child, but AI can. So what can AI do? AI can say, hey, this child is not ready to learn this concept. When this child has finished all the prerequisites, now he is ready to learn the concept. Only then the concept is introduced to the child. The concept can watch the best videos out there. The chat GPT can create the best content suitable exactly for this child, not a generic content like Byju's or Khan Academy. Then AI can produce the perfect homework assignment uniquely for this child, assess uniquely this concept for this child at their own pace. And once they have mastered, then they have mastered. And now what should we do? We should let the child teach the concept that they have mastered to somebody else. What will that do? We'll create a country where we develop empathy, we develop patience, we develop cooperative thinking and working together. That is how AI can help every concept, one concept at a time, the child will learn, right? So what have we done? This is what I call the journey mindset. So think of a child in a certain state, remember state, and we take a certain action, what to practice, what to teach next, and then, measure impact, keep doing it, and then the next concept, the child can continue. This journey mindset can be applied on health. What is your health journey? Can be applied on a crop, can be applied on a customer, right? A new customer becomes a loyal customer, becomes a valuable customer, becomes a must retain customer. So there is a journey of every entity, right? How do we think like that? I'm showing an example in the education domain, right? So, for example, student A has mastered the concept P and medium Q and very poor on R. Student B has mastered the concept R, medium in Q, poor in P. Today, what do? We teach both of them the same thing. Not done. So what should happen? The AI system will personalize education, and when student A opens the app, it will suggest that you are ready to learn concept X or R, and student B should learn concept P or Y, right? So this is a personalized learning for every child, right? So these are the ideas. We talked about personalized advisory in agriculture. personalized doctor for every patient. We talked about the real-time, crime detection and all that. Now, let me take you to two more examples, then we'll close. So here is another example. Now imagine a farmer. What is the first thing the farmer does in the morning? Does anybody know? What does the farmer do every morning?
Not very sure, but then probably looks at the weather and tries to understand what his next action would be.
Correct. What else? Anybody from the farming family?
They check
So
the
are you? Uh-huh.
status, the current crop, like what is the condition now, where he left
Correct.
yesterday, now what is the situation now.
Correct. So every farmer today in the morning, they take a round of their crop, figure out what's going on. यहाँ पे something, there are blisters here in the crop, there is some other problem here, some other problem, or everything is normal. So now imagine as he is walking around with the smartphone, he takes a picture of the crop, sends it to a system that detects the crop type and stage. Then another system says, oh, this is cotton stage 3. What are the possible diseases? These 5 diseases are possible. Another AI looks at the image and says everything is normal, or there is a water problem, or there is a nutrition problem, or whatever. If it detects water problem, what should it do? It generates an advisory based on whether rain is coming or not, what is the current moisture content, how much water do you really need, what is the size of the farm, and it calculates that you need 30 minutes of watering. Now that information can go to the farmer, but now imagine this AI is connected to the tube well system and it turns the tube well all for 30 minutes and tells the farmer that your watering has been done. If it's a nutrition problem, it tells the drone that I need this fertilizer exactly on this patch of this farm, and the drone will deliver the fertilizer. If it's a pest problem, it will deliver pest. Now, the farmer doesn't have to take a picture also. Satellite data can do the same, or drone data can do the same. So imagine a village has 3 drones. One drone goes around for all the crops, it figures out what's wrong. It is connected to the tube well system, to the 2 other drones, right? This drone and that drone. And now what does a farmer have to do? Nothing. So somebody was saying, right, earlier that we'll come to a state where AI will take care of everything. We don't have to do anything. And today we have labor shortage. We can take care of this, right? What have I done just now? I have reimagined health. I have reimagined education. I have reimagined agriculture. I have reimagined smart cities with AI. What is the core skill? Workflows, 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 right? Designing workflow is the core skill. And now this is not one workflow. These are 7 workflows working together. So one workflow finishes, it triggers automatically another workflow, right? So you see how workflows can trigger other workflows. I call this proactive intelligence, right? So the real problem to be solved is integration and interoperability, not accuracy. The models are all accurate. We can live with 90% accurate models. Even a farmer will make that mistake. But integration is the new thing. If we can integrate and create this, we are done. So today, what are we doing? Here is what I tell the government. If you fund 1,000 startups in agriculture, each doing its own thing without a master plan, what will happen? One startup is doing soil IoT, one startup is doing weather prediction, one startup is doing satellite data, one startup is doing supply chain of agriculture. What will happen? And 100 startups are building drones. Will anything happen? Nothing will
And
happen
the demand
because
supply chain will get
correct.
affected.
Need that, right? So the idea is unless we think of agriculture as a whole and not as different parts, nothing will happen. The startups will try to sell their app to the farmer, right? Each one. But we need an integrated operating system for agriculture. We don't need hundreds of apps for each domain, right? Like in whatever, right? So integration mindset is missing. Indians are very poor at that because we love jugaad. Ek chota problem, we do some jugaad, we are done. So we're not building smart cities, we are building slums all over the place. Why? Jugaad hai. So that jugaad mindset has to go away. We need to think top down properly, systematically about each domain, think about all workflows, think about all systems. Then only we'll transform the country. We'll not do it by funding 100 startups here and 100 startups there. Not going to happen. Yeah. Okay. Last one, and then we'll take questions. So now think about retail, for example. And what is the new skill that we want to develop is called the ecosystem intelligence. How to think about all the top workflows in a domain. So what are the workflows in retail, for example? One workflow is to get the orders, right? Somebody searched, somebody clicked on a home page, browsed, add coupon, orders are coming. The first workflow. What is the next workflow? We say, okay, based on the order, can I do demand aggregation? Which city, which brand, which location, which season? I can create a demand forecasting model. Now, what can we do? Now, the second workflow order triggers is allocation. Where should I deliver this product from to this customer? So when you order 5 things on Amazon, sometimes 5 different people will come to deliver the 5 products. Why? Because they have highly optimized for the following. So they are saying that this order, this product should be delivered from this warehouse because the inventory of the product is high in this warehouse and forecasted demand is low. So I will maintain good inventory across all warehouses. So that is their objective function and they are working on that, right? Then you have another workflow that says based on the orders, what are the profile of the user, right? You like blue shirts, red shirts. We talked about that. Now, what is the missing workflow in a brick and mortar retail? Is there a missing workflow or are we done with all the workflows? Any other workflow missing? Anybody? So one workflow that is missing is what we call the replenishment workflow, right? If the inventory is low and forecasted demand is high, how do we replenish? What have I done on this slide? I have not built a model at all. I'm not telling you how to build models. I'm telling you how to design an operating system for a domain. What does it look like? It looks like all the workflows and powering each other is an operating system. This is the new mindset I'm trying to develop now, right? So my students learn this skill. Apart from that skill, how to build demand forecasting model, how to build routing optimization, how to build recommendation engine are bottom-up skills. But how do you create an operating system for every domain? We talked about hundreds of domains is the new skill that we need to develop. Yeah. So let me stop here. I'll take some questions now. And obviously, if you want to do a follow-up, we can do more sessions. But I think the main thing that I wanted to convey, I hope I have conveyed. Yeah. Okay. Thank you. Anybody has any question?
Anybody has any questions?
We are all hungry now.
I'm not hungry. I am like, I heard all of it and it gave me a new perspective altogether. I loved your session and just wanted to, I mean, out of curiosity, this comes to my mind that today we are, as we discussed, we are living in a world where government also or everybody else is thinking about one particular sector. It's not thinking about the whole ecosystem. How can we change it? How can we get this new, mindset among everybody who's starting a new business or something that is new that is
Yeah.
coming up?
Yeah, that is the problem. That is the challenge for us, people like us who are trying to bring this kind of a thought process. So the other day, I was in the Western Command of Indian military in Chandi Mandir, right? That's where we did the Operation Sindoor, or Northern Command did that. They were talking about AI and they were again talking about use cases. They were saying we need to have radars, we need to have drones, we need to have satellites, we need to do this. This is how AI, this is use case 1, 2, 3, 4. Then few months ago, I was with Chandrababu Naidu. And when I said, we need to think top down, again, he was thinking, what are the use cases? So what is happening even at the military leadership or the state leadership, one of the best leaders in India in terms of thinking about progress of India is Chandrababu Naidu ji. And even he is thinking about use cases because that is the mindset we have developed right now. If I go to CIO conferences, I tell them that, look, you have created digital slums, you have procured point solutions after point solution for this, that, and the other. you have not built an operating system. They all agree because this operating system mindset has not come about yet, right? Today we are thinking agentic will solve this problem. Agentic will not solve this problem. Human experts who understand the domain will be able to create the workflows. These are domain people. These are not data scientists. The domain people should create workflows, right? Insurance domain, healthcare domain, all that. And then data scientists and data people and IT people should take that document, which says these are the 20 workflows in agriculture, and then build systems for it. Today, the problem is the domain people want something in bits and pieces. System people are delivering those things in bits and pieces. So nobody is thinking about the operating system. So now I have started to teach this philosophy everywhere to the government, to ISP students, to anybody who is listening. And slowly we are changing the mindset and slowly we'll start to build these operating systems. Yeah. But top-down thinking is a missing skill in the Indian education system and the way we think about the world. That's why Americans have built great cities. Look at Singapore. They think top-down, right? They think holistic first. What is a master plan? Then build a stadium. What do? We allocate a land and say, go build a stadium. We don't think about the consequences, right? So you see how we have to change that mindset. Yeah. Okay.
Thank you so much.
All right. So thank you all for your patience listening. Yeah.
Yes,
All
sir.
the best.
Sir, one second. Yes, thank you, sir, for your valuable time and insights today. So we gained a deeper understanding by the examples given by you. And yes, your session was practical, inspiring, and thought-provoking. Wishing you continued success, and we hope to engage with you again in the future. Thank you once again, sir. Thank you all.
Thank you all.
Thank you so much.
Thank you so
Thank
much.
you for the
Early.